Solve the following exponential equations. Record the equations you're not sure how to solve. I want you to take a moment, see if you can solve any of these. Okay. I want you to star anyone that you're not sure how to solve. Take a moment, try these. Okay. So what's the first one going to be? 2 to the x equals 2 to the third. What is x going to be? Wake up. 2 to the x equals 2 to the third. What is x going to be?
3 times 3 times, no.
3. Boom. Okay, so if it has that same base, we're going to set the exponents equal to each other, right? Okay, what about on the next one? There's no exponent, but what do we assume that is? 1. Okay, so x is going to equal 1. What about the next one? Okay, so let's try it. 2 times 2 times 2 times 2, that would be 16. So x would equal 4. Okay. What about this next one? How do we go about solving this guy? How do you know that? Okay, so what would be the first thing I do in order to solve this one? So move that 64 to the other side. Okay, so add 64. And so now we got 2 to the x equals 64. And you said it was 5. Let's try that. 2 times 2 times 2 times 2 times 2. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64, right? How many 2's do I got? 6. So x would equal 6. What about this next one? How would I go about solving this guy? Okay, so add 1 to both sides. So what would that exponent have to be? Anything raised to what power equals 1? 0. Too good today. All right, this next one's a little tricky, but let me rewrite this 64, because we just said that 2 to the 6th power is 64, right? So let me rewrite this guy. On this one? 2 to the first power would equal 2. So we added 1 to the other side. Yeah. Okay. All right, so on this one, we're going to rewrite it as 2 to the 6th power. Okay, so now that we have the same base, we're going to set the exponents equal to each other and solve. So we have 3x equals 6. How do I go about solving this guy? I'm going to divide by 3. So x is going to equal what? 2. Okay. Next one. How can I rewrite 32 as 2 to something power? 2 to the what? Yep. Okay, so now that I have the same base, I can set my exponents equal to each other and solve, right? So I can subtract 1. So x is going to equal 4. What about this last one? Can I raise 2 to some power to equal 10? Can I? Is it going to be a whole number? We know that 2 to the second is 4. 2 to the third is 8. 2 to the fourth power is 16. So this is not going to be a whole number, right? So what did we use all this past week in order to help us solve for x? Logs. Now, can you plug this into your calculator and solve? Yeah. So you would type into your calculator log of base 2 of 10. And when you do that, you're going to get about 3.32, roughly. Today we're going to solve simple exponential equations using logs. Okay, so bacteria population. A bacteria colony starts with one bacterium. The population of bacteria doubles every single day. Assume that there is a 24-hour reproduction time. The function P of t equals 2 to the t models the bacteria population P on day t. How many days will it take the bacteria population to reach 8 or to reach 16? Okay, so they have right here 1, 2, 3, 4, 5, and then they have how many bacterium there would be, right? And they want us to find it on day 8. So we're going to go ahead and continue with this table. So we're going to find 6, 7, 8. So what would I plug into my equation in order to find this y value? What would I plug into my equation in order to find when p is 6? So if I wanted to find this guy, I would say t to the 6th power. 2 to the 6th power. What is that going to give us? 64, right? 2 to the 5th power is 32, right? What about 2 to the 7th power? What is that going to give us? Okay. What about 2 to the 8th? Okay. What about 2 to the 16th power? They lost me. That's why we have calculators. Oh, I'm sorry. I totally read that backwards. Okay, so pause. Okay, so this is why reading is fundamental. Okay, so it said how many days is it going to take in order for the bacterium to reach 8? So looking at our table, when is our y value 8? What day? The 3rd day. I need a nap. Okay. To reach 16, we're going to look at when our y value is 16. What's our x? 4 days. I need a nap. Now, how many days will it take the bacteria population to reach 10? So looking at our little table, we see that in between here, right, would be 10. Like 10 is in between these two numbers. So we know that it would take between 3 to 4 days, right? But we can find it exactly by writing out the equation and using logs. So we have 2 to the t power equals 10. And we're going to use the circle of life to get log of base 2 of 10. And we just solved that earlier, actually, which means that t is going to equal 3.32. All right, so recall that b to the x equals y and log of base b of y equals x. So another way to solve 2 to the x equals 10 is to use logarithms. First, converting from exponential to logarithmic form. Okay, so we've already talked about this, but again, in order to solve this and rewrite it in log form, you're going to start at your base, go to the outside, and finish at your exponent. So go to your base, outside, and then exponent. Okay, and so that's going to be log of base 2 of 10 equals x. This next part is asking you to use change of base formula. And so what that is we're going to say log of this number over log of the base number. So change of base is going to be log of 10 divided by log of 2. So back in the day, before calculators actually calculated this, you had to put it in change of base form. Okay, this converts it back to base 10. Converts to base 10. Okay, and then obviously that would simplify down to 3.32. I'm going to solve exponential equations. Okay, so first you have to have it in the same base, or you can use logs to do it. Okay, and so what I mean by that is back in the day, you learned how to change this to the same base as this one and then solve from there. But now we can just use logs in order to help us solve. So when we solve this, we're going to start at our base, go to the outside, finish at our exponent. So this is going to be log of base 32 of 64 equals x minus 2. So now I'm going to take this and I'm going to plug it into my calculator on the left-hand side. So we're going to say log of base 32 of 64. And that's going to give me 1.2. But we still want to get x by itself. So we're going to add 2 to both sides. And so that would give me 3.2. The way that you learned it back in Algebra 1 is your teacher said you have to find a number that is like 1 through 10 and that you can raise to get this number. So for instance, y'all told me at the beginning that 64 is the same thing as 2 to the 6th power. Okay, and then you told me that 32 is the same thing as 2 to the 5th power. Now, since they have the same base, you can take both sides and set them equal to each other. I would distribute. Hey, friend. I would add 10 to both sides. And then I would divide by 5. And that would also give me 3.2. Okay, this is back when you did Algebra 1. Okay, but now since we've learned about logs, this is probably an easier way to do it. Okay. On the next one, we want to get this base by itself so that we can rewrite this using logs. But first, we're going to subtract 2. And then we're going to convert this into a log. We're going to start at our base, go to the outside, finish at our exponent. So we've got log of base 3 of 8 equals x. So when you type that into your calculator, you're going to get x equals 1.89. On the last one, you're going to divide by 5 on both sides. And that'll equal 6 on this side. The reason why we want to do that is because we want to get our base by itself. Okay, so that's the number that's raised to the exponent. Now we can use our logs to convert. In case you didn't know, Mike is out there. All right, and then we're going to plug this into our calculator. And when we do that, we're going to get x equals negative 1.49. Not you. All right. So where is the error? What did they mess up on? So if I have this problem right here, if I do 5 times 3 to the x equals 45, what's the first thing I always tell you? Divide by 5, okay? Because we want to get that base by itself. So what's 45 divided by 5? 9. Now what are we going to do? The log. So that'll be log of base 3 of 9 equals x. And so x is going to equal 2. So they done messed up. They multiplied together instead of dividing. Okay. So who do you agree with, Sarah or Kathy? How many of y'all agree with Sarah? I know. How many agree with Kathy? Okay, cool. Jermaine, you just got here. Kathy got a cool name. All right, cool. All right, so over here, they took the log of both sides, and then she multiplied by x out front, and then divided, but she got 5.6. Okay. Over here, we did the circle of life, and we got log of base 2 of 50 equals x. We did log of 50 divided by log of 2 and got 5.6. Both of them got the same answer, so why does this work? Well, you know how like we always say if you do it to one side, you have to do it to the other? Well, that's exactly what happened here. Log of this, log of that. And then we learned yesterday that we can take our exponent and we can pull it out front, right? So what Sarah did is not wrong. She just made it really complicated for no reason. But what she did wasn't wrong, so they're both right. Y'all were hating on Sarah because Kathy has a cool name.